All right, so we are finishing off the 2005 FRQ today. We did all of the Form B FRQ. I'm going to go back and do the last three from Form A. I believe we did the first three from Form A pretty early on during the online sessions. So objectives are to start working with tabular data for a function, for its derivative, second derivative in the function itself. And then determine the relative extrema of the function and its integral, as well as sketch the function. Okay, so here we've got a bunch of information about breakpoints for a function, its derivative and second derivative. And then what's happening on the intervals between those points. So we are continuous on this interval from 0 included to 4 not included. And we are twice differentiable for every point except x equals 2. Here we've got 2 points that don't exist. For 0 to 4, we want to find all values for which f has a relative extrema, and then determine whether it's a relative minimum, maximum, and justify the answer. So what do I have to do? Okay, so critical points first. Okay, so we have critical points at x equals 1. And then at x equals 1, so that was the point where our first derivative is 0. Is that a relative minimum or maximum? Our slope changed from, our slope didn't change actually, our slope went from positive to positive. So is that a relative minimum, maximum, or neither? Okay, so this is actually neither, because our slope went from positive, so that's increasing, to positive. So it looks something like that. So that's actually not a maximum and not a minimum. Okay, I've got one more critical point. Where's our last critical point? Right, at x equals 2, as the derivative is undefined. So we said x equals 1 is not a relative extrema. As f prime x doesn't change. But at x equals 2, it does change. So x equals 2 is a relative extrema. Is it a relative minimum or maximum? Okay, so we're looking at our first derivative. That's right here. Okay, so we changed from a positive slope to a negative slope. So would that be a maximum or a minimum? Maximum. Okay, so this is a relative maximum as f prime changes from positive to negative at x equals 2. Okay, any questions on part A? Okay, I'm going to take one more look at that x equals, one more look at x equals 1 instead. So at x equals 1, our slope went from positive to positive, which is not changing at all. Okay. So then part B. I'm actually going to do part B on the other slide, I think, so we're going to sketch. So I want to use this information to sketch all the characteristics of f. Okay, so I'm going to start looking at my x and y value. When x is 0, y is negative 1. When x is 1, y is 0. When x is 2, y is 2. And when x is 3, y is 0. Okay, so those are all the points we were given, so now I have to pass through those points. Then I'm going to look at my derivative and concavity, so slope and concavity. So from 0 to 1, from this point to this point, my slope is positive, but I'm concave down. So if I'm increasing concave down, my graph should look like that. Okay, then from 1 to 2, I am increasing in concave up. So increasing concave up. From 2 to 3, I am decreasing in concave down. Decreasing in concave down. So curving down, something like that. I'll do a little bit less sharp, maybe. It's a little hard to draw on this, but okay. So decreasing concave down, I've kind of got that little curve there. Okay, and then from 3 afterwards, I'm decreasing in concave up. So decreasing in concave up after that. Oh, let me actually stop at 4. Okay, we don't know the y value for 4, but I don't know I'm decreasing in concave up, so I should be curving like that. Okay, any questions on my curve? Okay, then 4 is not included, so I'm going to go ahead and draw a white dot at 4, just to say that we don't include that point. Okay, part C. So we're told that there is another function such that g of x is the integral of f of t from 0 to 4. I want to find all values of x for which g has a relative extrema and determine whether g has relative minimum or maximum at those values. Okay, so if g is the integral of f, then how would I figure out whether g has relative extrema? So last time you told me in order to have a relative extrema, what had to be true? Okay, derivative is 0 or undefined. So if the derivative of g prime x, is 0 or undefined, then we can check for a relative minimum. Okay, so if the derivative of g will be the derivative in terms of x of the integral from 1 to x of f of t, which would be what? I am going to set that equal to 0 eventually, but what's my general form first? So if I derive this integral, what will happen? From your formula quiz, if I derive the integral from a to b of f of x dx, what happens? Okay, this would be f of b, really close, f of b times, that's it, b prime, minus f of a prime. Okay, so that's what's going to happen here. So what should happen? Okay, so that's f of x times, okay, times 0, perfect. So that's just f of x. G prime x is f of x. And if that's true, and we set g prime x equal to 0, then g prime x will equal 0 whenever f of x is 0. Okay, where is f of x equal to 0? 1 and 3. Okay, so this f of x, not highlighting, this f of x is the same thing as g prime x. Okay, so at x equals 1, the slope of g changes from negative to positive. Is that a relative minimum or maximum for g? Okay, so here's x equals 1. G prime changed from negative to positive. That's a relative minimum. Okay. So relative minimum at x equals 3 as g prime x changes from negative to positive. Okay. And then we also said 3 was a critical point. So is 3 a relative maximum, minimum, or neither? Relative maximum for g, okay. Oops, wrote that wrong, didn't I? This first one's x equals 1, the second one's x equals 3. As g prime changes from positive to negative. Okay, any questions on part C? Okay. Then for part D, I want to find all values for which the graph of g would have a point of inflection. So if g prime is f of x, what is the second derivative of g? Okay, you're right. That's going to be where our point of inflection is. But is f prime or f prime prime the second derivative of g? I want to know, in general, the second derivative of g would be either f of x, f prime x, or f prime prime x. We said g of x is the integral of f of x. And we said g prime of x is f of x. So what's the second derivative of g? F prime. Okay. So this second line in our table, f prime, is also the second derivative of g. Okay, so with that, where would g have a point of inflection? What has to be true to have a point of inflection? Or, okay, second derivative is 0 or undefined, and it has to, okay, it has to change concavity. Okay, so one more time. We are looking at this line here for our second derivative of g. It is, we have 2 points to consider. Our point at here and here at x equals 1 and x equals 2, where our second derivative is 0 or undefined. Which one is a point of inflection? X equals 1 or x equals 2? Okay, you're right. Why?
Because of concavity changes it.
Okay, so I could say the second derivative of g changes from... I could just say changes sign, I think, and then would take that. But changes from positive to negative. Changes sign.